What is up, most distinguished patrons of this channel? Today we have a viewer request, and a ridiculous one at that, and not just one reviewer, but multiple reviewers over the past year have been hounding me to do this. Well, not hounding me, but you get the idea. And that is test JB Weld versus an actual weld to see how strong it actually is. So that's what we're going to be tackling today. Let's get into it. Now, I can hear you through the internet already screaming at your computer or your phone. Well, no, you dummy. Of course, it's not a substitute for welding. And I hear you, buddy. But one of the things I got to be honest about is that not only is it kind of a funny idea to test the strength of this, I'm kind of genuinely curious to see how strong this crap really is. Now, I'll be honest. I've never really used JB Weld to much success, primarily because it seemed like everything I needed to use it on was exposed to high temperatures, and it simply is ineffective at that. So, like, maybe some threads that are screwed up, you could retap and put a bolt in, but I swear, you know, if that happens to me, it's always on something that will burn or liquefy that epoxy, and it's just not usable. So maybe you had far better uses for JB Weld. I mean, no doubt, you know, I use it occasionally, but when you can weld, especially TIG weld, you kind of don't really need epoxy like JB Weld for the most part, okay? But anyways, what I did is I took 3/8 steel. Both of these are made out of 3/8, and we are going to bend them basically away from the face, aka the thickest part of the JB Weld. Now, let's be honest. We know this TIG weld here is not going to fail on a bend test. This is just from another video I made. So what we're actually going to compare these JB welded plates to is more or less a 1/4 inch TIG weld. And I'm going to try and make a 1/4 inch stick weld. That'll be a little bit difficult simply because that's about, you start the rod and you're done. And we're going to bend test both of these against very small actual welds to compare and contrast the strength. Now, as with any of my videos, I never do a dry run for any of this stuff. So kind of what happens, happens. And maybe if this turns into some kind of utter failure, maybe I'll revisit this in the future and try and do something different. But for the sake of what we got today, we're just going to bend these and see what happens. Now, they are slightly different. This one right here, I more or less just put JB Weld between the upright plate and the flat plate and just kind of wiped it off, so no reinforcement. This guy right here, I kind of made a fillet weld of, a very poor fillet weld. I might be able to weld, but JB Weld is a whole skill in itself. But I wiped it a little bit flat, so there is a lot more of this goop on there. Now, both of these JB Weld test plates were done, I don't know, 2 weeks ago or so, so they've had plenty of cure time, and it's a little cold in the shop here, but I'm going to make sure these are at least at 60 degrees so they're not overly brittle. Now, one of the interesting things I will mention here, because, you know, why not throw some educational garbage in it, is that JB Weld works under the theory of cohesion. It's more or less like a glue, and the more of it, typically the stronger bond per se, within reason. When you actually weld something, you're fusing them together. That is a completely different process, which obviously, you know, it kind of goes with welding and fusion and penetration and all of that. So that totally makes sense. But more or less, like if you ever do brazing, brazing functions more like JB Weld, where it's a cohesion process. The difference is, though, is that brazing, I have a feeling, is far, far stronger than JB Weld. And maybe in the future, at some point, I'll do an actual bend test with brazing with TIG, with silicon bronze, just to see how strong that actually is. If that's something you're interested in, let me know. And if enough people suggest that I do that, I definitely will look into that. And going back to the cohesion issue, and this holds true for brazing as well, you generally want to way oversize what you have in comparison to an actual weld to get any kind of reasonable performance. But even with that said, I don't think that either one of these are going to perform real good. So with that said, I'm going to get 2 more sets of plates and I'm going to weld them up with super small welds, and then we're going to come back here and start the testing. So I am back. I managed to get these 2 guys welded up, and well, this one is pretty atrocious. So let's talk about this first. What we have here is about a 1/4 inch TIG weld, single pass, about 130 amps, 1/16 filler. Very small little weld. I didn't even really push that much filler, so it's a bit concave, not really a desirable profile. But for what we're doing here, I think it'll be just fine. And we have to make this test fair, because I know if I would have welded this straight across, that I could fully bend this without a failure, and it would have handled a tremendous strain that in pounds, well, in pressure, to bend that. So to make it more fair, smaller weld. Now this little guy here, which I happen to weld with 1/16 size 6013s, because I didn't have any 332s and I wanted to make it again somewhat fair, I put this down, and at the max recommended amperage for this little guy is of 58 amps, is nowhere near what you need to weld 3/8 plate with. Now, I managed on part of this to get what appears to be fusion between these two, but that start, man, oh man, is that sucker suspect just looking at it. Hard to say, but again, you know, for the sake of kind of the enjoyment of this, we got to give JB Weld a fighting chance, right? It's just like with statistics. You can prove anything you want if you doctor the numbers. Well, we'll see how well that does. But anyways, let's do the first test on all of these. So I figured, since why waste the time putting it in a shop press if I can break it by hand? I'm going to attempt just to pry this in my hand and see if I can break this, or that either one of those. Let's see what happens here. Well, I won't cheat. I'll use one hand. Well, 2, screw it. Nope, can't break that. And remember, my grip strength is actually pretty good, so if I can't break that, that's more than 150 pounds. Yeah, and that, I can't do anything with that. This guy, yeah, nothing there either. So, well, uneventful. Now what I'm going to do is I'm going to take and drop these. Oh, I'm not going to do this one, by the way. That one didn't break. Why risk my hand? Let's take these and drop them on the table one by one and see if just impact forces cause failure. Oh, that didn't break. Didn't break. Shockingly didn't break, and I know this one's going to be good. All right, it's at least glued together good enough. Let's go and break them in the shop press and see what happens. Well, I have this stick weld here. Well, I can't really call it much of a weld, more or less a spot weld. Kind of ashamed to even say I did it. That's pretty atrocious. That's sad. But I'm going to shove it in this press here, and we're going to watch how many tons of force, well, more like pounds of force, because I don't think this thing is going to take that much before it breaks. But let's see what it'll do. And it broke basically with no force. And to be expected, very crappy weld. Too bad I didn't have any 332 rods. But hey, it did something, right? Now let's take the TIG weld, which actually has some fusion, and let's see what we can get up to on this. This, I have a feeling, we'll get at least some pressure on it before it fails, due to the fact it does have some fusion. And that dickered right off, and luckily I'm standing off to the side of the press, and I kind of figured that would happen. Now keep in mind, a lot of that force that we're putting on it isn't actually being put on the weld itself. It's being pressed into the plate. Until that top plate bends, we're not really stressing the weld that much, but we actually put quite a bit of force on that, shockingly enough. Well, now we have the thin JB Weld, where it's basically just between the plates. And by the way, I did prep these as good as you can get and gave it a really good surface finish, aka rough, to try and get this to at least adhere. I have a feeling that this is going to perform about as bad as that little poor, barely fused stick weld, well, spot weld on there, but we won't know until we try it. So let's bend this. And it broke pretty much instantly, and it looks like the JB Weld actually failed. We'll have to look at the other plate, but I see JB Weld on this side. All right, well, the moment of truth. I don't think that this big monstrous glob, we'll call it globular transfer of JB Weld, I don't think that that's going to hold up better than that little TIG weld in any realm, but let's find out. Actually, I got to put it in this way. All right, we're got a little pressure on it. Let's try and bend it. Yep, barely got any pressure on it, and that was it. Failed. All right, well, let's go to the welding bench. Well, let's talk a little bit about the results there. I got to say, I wish you guys were here to help me find where that TIG weld went, because it blew under the welding table and was sitting in a place I couldn't see it, and I looked for it for 10 minutes before I found the bastard, so wish I had help. Anyways, stick weld, atrociously bad, and I kind of expected that. I wish I had 332 rods, and I can tell you right now, had I ran an equal length weld that was with a 332 rod at maybe 60 to 90 amps, it wouldn't have failed at zero pressure. So that's really more or less an issue with the fusion, but it may be a whisper, but we'll give that a big, ugly fail, a frowny face. That's not a good weld or a spot weld. So that lost, but again, that's more me and my situation. Now the TIG weld, that shockingly enough held up to approximately, I'd say around 5,500 to maybe 6,000 pounds of pressure. The way that the camera was on the gauge was a little bit at an angle, so it's what it looks like to you is a little bit off from what it actually was, but we're close to 3 tons. That is a tremendous amount of pressure. I mean, that's the weight of like a common two-door pickup truck on that fillet weld before that little bit of weld failed. Now, would I use that as a jack stand? Absolutely not. Not in the wildest dream, because that was just static pressure. I can't even imagine, you know, you put 800, 1,000 pounds that wiggles that a little bit and it's going to fail almost immediately. So for static pressure for that little bit of weld, that's actually a lot higher than I would have expected. Again, though, and I'll talk about it in a minute, most of that pressure is not actually being put on the weld, and I'll explain more about that. But anyways, JB Weld thin, somewhere in the ballpark of 800 to 1,000 pounds, or about a half ton before it failed. Now, one of the things I noticed putting pressure on it is I didn't feel it really get hard, like I was putting any effort into it, and it failed. I have a feeling that if I would have held it at, say, 500 pounds, so like a quarter ton, and just let it sit there, that it would have failed anyways, because that material was probably starting to stretch. So very realistically, it broke at this because of how fast it kind of ramped up in pressure, but I think somewhere far lower it would have failed over time, like over a few seconds. So pretty weak. Granted, I only put it between, you know, just enough between the pieces to cover it, but I wouldn't be trusting this stuff to make jack stands any day of the week. I would definitely buy Harbor Freight jack stands and let those collapse on me over that. Now the JB Weld thick, that shockingly enough hit about a ton, somewhere between 1,800 pounds and 2,000, which is stronger than I would have thought in this test, but realistically it goes back to the same curve here. I have a feeling at somewhere around 1,000 pounds, if it just sat on there, that it would have failed in a matter of seconds, and I just sped up the process. So we could say its yield strength is somewhere with that quantity on it, somewhere around 1,000 pounds, and its ultimate tensile strength is somewhere around 1,800. So better than I thought. But when you compare that to that minuscule TIG weld versus that, there's no comparison. And it's pretty amazing how strong an actual fusion weld is, even on the smaller side, in comparison to epoxies. Now, at some point, if I put double the amount that this had on it, it probably would have got higher. But again, it still goes back to that issue where, well, how much do you really want to put down on there? You know, are we going to fill it 2 inches out in every direction to try and hold it together? Clearly not the right product if you really need strength. So with that said, let's actually look at these plates. So with the first JB Weld, where there really wasn't a whole lot on it other than basically between the plates, it seems like the JB Weld stuck to both plates decently, maybe not as good on the bottom plate, but it kind of stuck to both and just tore. I mean, this material simply just couldn't handle the pressure. But the fact that we got any reading at all is honestly better than I would have thought for this material, for this quantity. And that's why, like, when you add more, we saw far, far better results, like with this guy. When you look at this, so it really is still stuck mostly to the plate, especially down here. You look at that. So honestly, this is just a material failure. It simply couldn't hold up to the pressure, but I'm kind of surprised how well it actually stuck to both the pieces of the base material. Obviously, a lot better results when you slap it on thick. So if you ever have to do a repair with this junk, you know, the thicker it is, probably the better the results will be, because again, it works on cohesion. It's a glue more so than it is fusion, obviously. Now the stick weld, you can see how absolutely atrocious that is. I mean, basically the only part that actually glued anything that broke is this right here. So you're talking maybe an 1/8 inch, 3/16, you know, somewhere around 3 millimeter. And that's pretty sad right there. That's basically the only part that stuck. All of this wasn't even adhered. It was just sitting there. And we saw barely even a whisper. Had this been this size, but better fusion, aka running a rod bigger than this little guy to do it, it would have performed likely very similar to the TIG weld. So it would have been up in the 2-ton, 3-ton range, very realistically. So again, nowhere near as weak as JB Weld. But it does go to show that if you can't weld and this is what you're putting down, maybe JB Weld is an option. And then the TIG weld, where we have more or less perfect fusion for about, it's a little bit longer than 1/4 inch. We'll say 3/8 of an inch. So somewhere, I don't know, around 5-6 millimeter. And that handled quite a lot of force pretty easily, actually, and it broke right through the weld, which is to be expected, especially with that small of a weld. There is no visible bend to the plate. Very little by the look of it. So, but still pretty strong. Well, let's talk a little bit about the stress that this saw and kind of why things happened the way they did. So this is obviously a kind of a janky BS test to be testing this, but we learned a lot for what we did. The main thing I want to talk about is doing a bend test like this is kind of, how do I put it? Not disingenuous, but the way it loads a weld is, well, if you can see here, as I push down here, there's a lot of force simply going into pressing that into the plate, like on a shop press. So initially, a lot of the force that you're going to see reading is simply the force of pushing it straight through the plate. Only when this upright plate bends, where this weld starts actually getting loaded on the toe of it, does the weld actually see a lot of force. So in the reality of what you saw here today, JB Weld, if it was actually holding something more like this, and where it's equal on both sides and you put weight there, it wouldn't even handle probably 200 pounds before it failed. Most of what you saw was simply, like I said, pushing this plate into the table or into the shop press. So the ratings are far higher than any kind of practical rating you would find on this. So no, don't go repairing your jack stands or motor mounts with JB Weld, or for that sake, doing little 1/4-inch welds with no throat depth and think that you're okay. Now, even with that said, the TIG weld hit 3 tons, about 6,000 pounds pushing down on that, which is pretty amazing when you think of it. Had that been fully welded out, that little weld would have easily been able to handle this being bent significantly without failure. So pretty amazing how strong even small TIG welds can be because of how perfect and uniform that fusion is. But anyways, with all that said, I had some fun doing this, and I got to say the JB Weld is stronger than I would have thought, but it's no substitute for even brazing for that matter. And, realistically, JB Weld, I tend to use it for like plastics and kind of other oddball stuff like strip threads on non-critical, non-heated stuff, but like I've just never had much luck with it on vehicles and a lot of things simply because of the heat and vibration. It just doesn't take well to those things. But for things that you would glue together, it can work really well, especially their plastic epoxy works pretty good for random crap around the shop. Well, anyways, if you got any ridiculous stories about things you JB welded together that held, leave them in the comments. I'll read them and get a good laugh, as will, I'm sure, other people. And I'll share one that I heard that from a reliable source. I do believe that somebody did this. So a heavy duty diesel motor, so you're talking something out of a garbage truck or a dump truck, at a shop, basically had spun a main bearing on it, and it wrecked the bearing cap and the block, and they didn't want to send the block out to be basically overboard to get bigger bearings in it to make it work. And they actually took new bearings, put them in there with JB Weld, bolted it together, let it sit overnight, and ran it. And apparently, again, I didn't verify this, as in I didn't see it with my own eyes, apparently that engine is still running today. Now, I gotta be honest with you guys, for one, I would never do that unless it was to get out of the mountains of Afghanistan. But two, I don't know how the amount of heat that would be in that area. I would think it would cause a failure. Like, heat is JB Weld's enemy in my experience. But at the same time, considering how well this actually stuck to both the materials, they're both the same, to clean material, I almost think that it might work and that bearing shell wouldn't spin, but it's still ridiculous, especially in a diesel that has all that tremendous amount of force. But who knows? Like I said, if you did some kind of janky repair with it, let me know so I can get a laugh out of it. Anyways, hopefully you enjoyed the video, and I don't know, I'm not really too surprised at the results, but JB Weld is nowhere near as strong as even a small weld, unless you're terrible like I was. Don't be terrible. Until next time.